Okay, let's do it. Welcome to the eighth episode of MEV Space. My name is Brian. I'm the Chief Content Officer of Eigenfi. So MEV Space brings together the sharpest minds in crypto to dissect the evolving MEV landscape. Today, we're going to discuss encrypted mempools. So for years, we've treated the public mempools like an open air market. It is great for transparency, but it's terrible for traders because they're getting sandwiched and protocols are actually leaking alpha. But in 2024 to 2025, it's kind of flipped the script. So we see Shutter Network, Espresso, MEV Commit, ADS, and even BuilderNet. So this kind of solutions actually hide transaction data until the other game is locked while giving users privacy. But some of them actually not that good. We'll talk about that later. So we have special guests from Shutter Network and Nethermind to dive deep into this encryption pools and debunk myths about such solutions. So I'm gonna let our speakers do a round of self-introduction, including our co-host. So how about Luis? Could you please start? Okay.
Thank you so much for having me. Luis here from Brainbot, product manager at Brainbot for Shutter Network. I've been working in the protocol and sort of infrastructure space since 2016 in Ethereum, and now fully focused on Shutter Network. And Shutter is essentially a threshold encryption as a service mechanism. So you can essentially protocols or other use cases. For example, we also have non-MEV use cases, non-encrypted mempool use cases, which is to do with voting, for example, and a snapshot, which uses it for shielded voting. So these sort of clients can sort of buy encryption, decentralized encryption from Shutter, encryption, decryption, and the nice property that this threshold encryption approach has, it is sort of unstoppable. So it is guaranteed to decrypt as long as the trust assumption holds, and that makes it ideal for this use case of encrypted mempool, which we've built out together with Gnosis Chain for now for a POC essentially to show that we can have an encrypted mempool to prevent front running and malicious MEV and real-time censorship, and now really looking to bring it to Ethereum L1.
Great. Next we have Mark, who's a first-time guest here. So Mark, would you mind introducing yourself and the single most concrete thing you've been researching on encryption tools? Thank you.
Hi. Yeah, great to be here. Nice to meet you guys. So I'm Mark. I work at Nethermind on the Ethereum core team. I've been doing that for a couple of years, like working on various EIPs and kind of bits of implementation and research. But I worked on the implementation of Shutter integration with the Nethermind client, which is being used on Gnosis, and I've also proposed a couple of EIPs around encrypted mempools.
Okay, cool. So yeah, I just want to mention that we should have AJ of Radius here, but AJ had some accident this morning, so he couldn't be here. We wish all the best on him. So next thing we have Ben as our co-host.
Yeah, I'm Ben. I'm the VP of Engineering at BTCS. I lead most of our developer operations at BTCS. Very excited about encrypted mempools. Hoping to be able to help out with the implementation of it on Ethereum L1. I've been talking with Luis a lot about that lately. Ideally, we'll have something cool to show with that in the coming months. But yeah, very excited to talk more about encrypted mempools today.
Nice. So yeah, Ben, would you mind start a question?
Yeah, for sure. Yeah, so what would you guys say is the biggest myth people are holding now about encrypted mempool solutions, and why do you think that myth persists? Let's start with Luis.
I think most people think that it prevents. Think that the claim is that it would prevent all MEV, and then they rightfully say that it can't do that. So we think in general it can prevent front running. It cannot prevent back running, nor is it actually maybe desirable to prevent back running. yeah, we saw that there was a really good, or in general, it was good from A16Z. There was this analysis of encrypted mempools and some of the potential drawbacks. But yeah, so the headline was really like that, what I just said, right? Even those researchers, analysts from A16Z, they sort of seem to have this misconception that the way an encrypted mempool works would be trying to prevent all MEV, and then their conclusion is, well, it fails to do so, and they say kind of the quote is, "It's not a silver bullet," which of course that's true, right? Because but that's because the goal isn't even that, and it's clearly understood that the way it works, it cannot prevent backrunning, yeah, nor does it aim to do so. I think that's probably one of the biggest.
Mark, any other myths about encrypted mempools or anything that you want to clarify with the community about it?
Yeah, I think I agree with Lewis. That's probably the biggest one. I mean, I'd say one common kind of misconception that I've heard people have is that it's like a privacy thing, which it is in a way, but it's all about only short-term encryption. So as we kind of talked about, it can help with censorship resistance and front-running protection, but the kind of encryption is just like a short-term privacy solution. It's not giving you any kind of like long-term privacy.
Okay, so yeah, my next question is gonna be a little bit spicy. So yeah, I was just on the other like Twitter space like 30 minutes ago. That was held by Kristen Kim, talking about the incoming upgrade such as like Gloomstone. They're gonna like can try to implement like EPBS into the incoming upgrades. But why isn't like Ethereum Foundation prioritizing like encryption pools? So because I've heard all kinds of rumors about like how this like politics kind of like impacting the development of Ethereum. So like Mark, like could you please name one of the blockers you think is like the stopping encryption pool being implemented in the L1?
Yeah, I think there is interest in encrypted mempools, but it's just not really a priority. Like I said, in the short term, kind of scaling, maybe Fossil, like lots of these other things are kind of the priority. But I have kind of been working on this and speaking with various people at the EF that are also kind of looking into this problem. And I've proposed a CIP, which I'm hoping can potentially be in Glamsterdam, which would kind of add support for or kind of help to support encrypted mempools like Shutter. And I kind of think that potentially a lot of this doesn't actually need to be done by the Ethereum Foundation, like similar to how we have, you know, L2s where they're kind of somewhat maintained outside of the core protocol. Like certainly for the short term, I think we could make some small protocol changes on the L1 and then the majority of the sort of work would be done by, you know, people like Shutter or whoever else is developing them. So I think we're just not really at the point where it makes sense to put everything into the core protocol yet. Like I don't think we've kind of solved the problems.
So Luis, what's your take on this?
Yeah, would agree with Mark. I think there's a number of reasons. One being that misconception that we touched on before, that is kind of misunderstood, right? I think one other is there is, I would say, a little bit of a people who are active in the MEV space or are who are knowledgeable about these things. They might some of these actors, some of the actors in the PBS transaction supply chain who are then also like influential in those discussions. What should be implemented at the protocol level might also be really sort of like an incentive not to be that interested in preventing MEV, kind of on the higher level, right? Although I think that touches on that misconception where I think everyone sort of agrees that front running will have to be going away. So that's kind of like that's probably why some actors and some people who are involved are again might be even disincentivized. But again, I think it's a misconception because the front running will be going away anyway. So that's one. And then a little bit of sort of implementation complexity that we have to get around. And then also, I guess a big one is, I think, because on the encryption, on the kind of cryptography side, or on the technology to encrypt side, unfortunately, there's probably not a perfect solution right now, right? So unfortunately, there is no way essentially to 100% reliably, trustlessly encrypt something. Well, to encrypt, you need to encrypt with a key, right? So unfortunately, it's not like in blockchain transfers or something where you can say you just fully decentralize the validation of transactions, unless you have kind of the more people validating transactions, the more the safer it is essentially. With encryption, there is no like someone needs to hold the keys, right? So depending on all the cryptography options that we have some kind of trust assumption. Either it is in the threshold encryption case, it is sort of that there is at least a certain subset of the decentralized network of committee nodes that is honest and not colluding, and then for something like TEEs or VDE or VDFs, it would be something like a hardware trust assumption, right, where you need to trust the hardware, which is something that's definitely, I think, probably not really interesting to the Ethereum Foundation to enshrine at the protocol level. But yeah, so I think that it's a mixture of things. But I think the good news is that all of these are not kind of 100% blockers, are more just like difficulties that are being overcome as we speak. And as Mark said, there's definitely an interest as well. And you see like Vitalik in, for example, this one of these blog posts really mentioning encrypted mempools as a solution to a lot of problems. And especially if you go into this, what Mark has called the holy trinity for censorship resistance, this kind of Fossil, EPBS, and encrypted mempool, if it really becomes apparent, I think, if you dig into this, that it is the solution, right? Flashbots did this really cool answer to the current Glamsterdam EIP lineup and Fossil and EPBS. And one of the criticisms they have about EPBS is that there is a free option, problem, right? And that essentially the builders can choose to, if they see something that's going against them, they can choose to not to include an empty block essentially. Right, and then you have a lot of empty blocks, and that's one of the criticisms, and that is sort of exactly, ideally, something that threshold encryption can, this concept of threshold encryption can solve, this type of free option problem. And we think that if Fossil, EPBS, and encrypted mempool work in this trinity, then that free option problem should be eliminated, and that option should not even be usable, essentially.
That's awesome. I feel like I've seen that there's like a higher threshold or like a higher barrier to entry for some features, while we allow kind of short-sighted solutions that 98% of blocks go through out of protocol. Like, for instance, like PBS going through relays all out of protocol for block building. I feel like that was kind of accelerated through while we require such like a high I guess like solved solution, very thought out solution for some of the like other features out here. So it'd be nice to start with good enough instead of perfect for some of these things. But I think that's kind of part of the accelerate mindset recently. So hopefully we can we can move a little bit faster on some of these cool features. Let's
definitely.
Oh, what's that?
So just that, as you said, definitely, yeah.
Yep. Cool. So we already talked about how this doesn't really block MEV. It may block some toxic MEV, but what are some unexpected bonuses from encrypted mempools?
I think the I think the major one, and that might even be the major one, is censorship, is real-time censorship resistance, right? Where I think we have on a high level, I would say blockchains solve that transaction ordering problem on longer time scales, and we have, and especially then censorship resistance, right? For longer time scales, so you can even if you only need one validator who doesn't censor, right? So then eventually you could get even the most contentious kind of censored transaction, tornado cash, whatever transaction, in maybe it'll take, a year or something until that one validator who doesn't censor gets to it, but you will have like eventual censorship resistance. So we solved that problem, but we really didn't solve it on short time scales, right? So then there's this really cool old blog post from Vitalik, I think 2018 or somewhere in between, around that time, where he talks about this difference and sort of like how sometimes you could argue, well, the real-time censorship resistance that doesn't matter that much. You can just wait, right? And it might be true for some people, like criminals who just, they don't care if it's going in like in an hour or 2 hours or whatever. If they just have like the source of it, or the target is like an illicit target or something, sure, then maybe they don't, maybe that's, for them it's not even relevant, the real-timeness of it, it's just relevant that they get it through at some point. But Vitalik makes this really cool example where he says real-time censorship can be really important. Let's say you have in trading, basically, right? And let's say you have an options contract, I think or futures or option contract he's referring to, where only once a certain price is hit can you exercise the option, right? And maybe it doesn't, maybe it's only hit for sort of seconds or minutes, that target price. In that case, real-time censorship kind of can really kind of make or break someone's profit, right? If you then are sort of DOSed, or if your transaction is then censored in that instance, you then lose the opportunity to use the trade use the opportunity to exercise an option, right? So that's I think one example of kind of real-time censorship. Another one was with this Sonium, the Sony L2, and for L2s, that's kind of the most apparent is the difference between real-time censorship and longer term. So L2s, you always have censorship resistance because you can push through the transaction on L1, right? So eventually you'll have censorship resistance. But then the sequencer can just censor. The sequencer is centralized, so real time, kind of on shorter time scales, the sequencer can just censor. And that's what they did, right? There was like malicious, or in that case, in their view, there was transactions or meme coins that they didn't appreciate being on this kind of corporate L2 in that way, right? So they were just like ignoring or censoring those transactions, and people lost a lot of money because in this meme coin trading, or in this world, time matters a lot, right? And people lost a lot of money. You can push. Eventually, I think someone pushed through stuff on the L1, but like to them that didn't even matter, because in the time they lost all the opportunities and lost all the money in those hours that they were censored, right? So I think real-time censorship resistance is the big one, sort of as a benefit. And then I think, if you frame it differently, again, I think the other benefit is alleviating problems with the other stuff, right? As I touched on before, there's like if EPBS current EPBS proposals come with a free option problem, then hopefully threshold encryption can solve it.
Mark, anything to add?
Yeah, no, I agree. Like, censorship resistance is definitely the kind of main other thing. But I just want to highlight kind of how it would interact with Fossil, because Fossil is the kind of main censorship resistance kind of solution which is being proposed. So I mean, Fossil does kind of provide censorship resistance on its own, but when used also in conjunction with encrypted mempools, it can give you some extra benefits. And I think there's kind of two different benefits there. So the first one is that if you just use Fossil, then essentially you can get the censorship resistance, but without front running. So before you could go through some like private mempool, and then you can actually, avoid getting front run just by trusting the builder. But to get the benefits of Fossil, you actually have to go through the public mempool. So then you don't have any kind of front running protection. So if you use Fossil with the encrypted mempools, then you're going to actually get that front running protection as well using the encrypted mempool. And the other benefit, I think, is that Fossil relies on 16 includers. So these are 16 kind of people who are looking at the mempool for sensitive transactions and then kind of forcing the builder to include them. So normally they would just be looking and there would be a bunch of, unencrypted transactions that they're going to put in this list. But when used in conjunction with encrypted mempools, like now there would be potentially including just some encrypted ciphertext. So the difference there is, if for whatever reason the includer didn't want to include your transaction, now they don't actually know what it is. So there's less of a reason for them not to include it. And they could also have, plausible deniability if they're kind of worried about getting in trouble for including a certain transaction. So yeah, just to summarize, like it just gives even more censorship resistance than just Fossil on its own.
Oh, awesome. So yeah, before I move on to the next question, so I just want to open the ground to the audience. So is there any questions that you guys want to ask? Please raise your hand. Okay, so yeah, I guess you guys can ask question later. So as long as you have time. So yeah, my next question is like, critics says that encryption actually adds yet another moving part to an already like complex R1. So why is that complexity worth it? And where can we abstract away? So Mark, would you mind start?
Yeah, so I think it depends how you implement the encrypted mempool. But generally, kind of as we were speaking about before, I think a lot of it can actually be done outside of the sort of main L1 protocol. So in that case, it doesn't add too much kind of complexity there. In terms of complexity on the user side, I think all of this should just be abstracted away from them in their wallet. So, their wallet will handle the encryption, or maybe a smart wallet kind of module will handle the encryption, and the user won't have to think about it, ideally.
Okay, Luis.
So maybe that's two questions, right? How can we assert it away, and why is it worth it? So maybe let me tackle the first one. How can we extract it away? I think Mark gave a really good answer. I just want to add that I think ideally we would have a generalized encrypted mempool interface, or generalized kind of mempool encryption interface, where it doesn't matter which type of encryption method is used, right? So that all the encryption stuff is abstracted away. It doesn't have to burden the protocol itself, right? So and then people could build different threshold encryption type methods. People could build verifiable delay types, time lock encryption, encryption methods. Maybe in the future, homomorphic encryption, or TEEs. Yeah, so I think that's also one way to abstract it away. And then why is it worth it? Yeah, because I think it's because of the censorship resistance, right? Like that's kind of the main value add. Why would you have a public blockchain? Is to me is about censorship resistance. And that's why I think it's worth it. If it levels up censorship resistance just by a little bit, that's the biggest value add kind of you could have as a chain, yeah. And I think in the past, or if you just think about Ethereum as maybe just serving kind of Western interests or something, or let's say in a smaller world, then censorship resistance might not even be that important. But the more it becomes sort of global, and the more you'll have things like, national strategic reserves, including Ethereum, and having sort of countries that might be opposed to each other, might be enemies, or big institutions that might not trust each other, because it's really like a global level, and there is even maybe not even legal recourse for them on this kind of supranational level. I think the more it becomes really important to have censorship resistance, and just simply speaking, sort of like China won't want to deploy their national reserve on a network that might be controlled by entities that are only in the US or something like this, right? So I think that's why it needs to be really neutral, right? It needs to be censorship resistant.
Yeah, I think that's a good point to bring up, that we're not just the United States of Ethereum. We need to be more globally minded with these things and add to the censorship resistance. So with all this added complexity, kind of infrastructure costs and latency, who foots the bill, and how do we ensure that validators don't lose revenue? And do we incentivize any actors to be running this infrastructure? Do you guys see this as like a validator duty, or do you see this as like a out of protocol goodwill actors in the space?
I think two answers depending on how we would implement it, right? So I think longer term, it should be just part of the fee, right? You're paying for transaction ordering, you're paying for transaction kind of validation, but you're just paying for, essentially you're paying that for censorship resistance, right? And then and for a trustworthy exchange in the marketplace, right? So that should just be sort of part of the fee, and just like you don't think about what everything is all the validation steps or whatever consensus steps that are happening in Ethereum, just like that, you shouldn't also as a user care about what transaction ordering or encryption steps are happening in between. So that, to me, that longer term is just sort of like, just part of the fee, I would say. And again, I think it provides value because that's the value that Ethereum provides, is censorship resistant and kind of a fair and trustworthy marketplace. And then shorter term, let's say if we talk about this, including the building the encrypted mempool in such a way that it plugs into the already existing PBS supply chain, then I think there's the interesting point to make, that basically there is a little bit of if it's not really forced upon people, right? If it's voluntary, then there is an intrinsic, then there might be an incentive for some people, or overall it might reduce the amount of MEV, which then reduces the income for validators or builders, right? So on that global level, it seems that it could be even sort of like, it could be a disincentive if we build it sort of in this out of protocol PBS way. But the interesting part there is it might not be, right? So it might also be, you might also just think about it from the other perspective and say, well, it'll be a new it'll be a new transaction type that those builders or validators, depending on how you build it, proposals can accept and can get paid for, right? So, and then people just need to pay for it, and then as an individual entity, including transactions, from that perspective, it's just an additional flow of transactions that you can process because you have the capability to process encrypted transactions, right? So on that level, the user would pay, right? And then this might actually be even like attractive to those individual transaction supply chain actors that are then being able to process this new transaction flow.
Mark, any thoughts on the kind of like the payment dynamics for this?
Yeah, so in terms of who pays for it, I think it would be the user, kind of just having some kind of small extra tip in order to use the encrypted mempool. And I don't think that, well, I mean, validators, I think, would generally have an incentive to run it because they're going to get essentially additional order flow, so just more transactions paying tips that they can include in their block, and potentially some kind of rewards from kind of participating in the encrypted mempool. So this is the kind of extra tip, which could go to the validator as well. Yeah.
Cool.
Oh yeah, sorry. There's also about the extra latency I think you asked about, which I also don't think is necessarily a big problem. So I think that normally, in kind of most designs that I've thought about, there would be one extra slot of latency. So in the first slot, you put your encrypted transaction on chain, and then in the second slot, the unencrypted one would be included. So I think generally, if you're really worried about getting front run, then this would be kind of worth the wait. And you can also consider that sort of even just once the first slot's happened, once the encrypted transaction is on chain, then you actually still have a very strong guarantee that will be included in the next slot. So you can kind of have some confidence that yeah.
Nice. This actually reminds me, I want to ask another question. It's kind of along these lines. If we do an out of protocol encrypted mempool first, do you guys see any centralization risks on there of where order flow could land?
And what would be where would it centralize?
If there's only a single entity providing the encrypted mempool support or transaction encryption, do you see that as a centralization risk, or less so of that and more so just another feature of an OFA?
I'm not super worried about that centralization risk, right? Because it's not like other centralization risk where it would sort of enshrine and kind of provide extraordinary opportunities to someone, sort of like, so I don't see that. That's less about the centralization risk. I think that's more about just will it work well for the user or not, right? So if there's very, very few validators accepting transactions, it would mean or builders, right, depending on how we use it again, then that increases the time that your transaction takes until it's processed.
Yeah, in terms of kind of centralization, I mean, if the concern is that it would just be the same, everyone using the same encrypted mempool, I don't think it's a problem as long as the threshold set. So that's the kind of group of parties who all kind of collectively own the key and can collectively kind of, when 2/3 of them come together, are able to decrypt the transactions. If that set is kind of sufficiently decentralized, then I don't think the system is centralized as a whole. And also potentially you could have different encrypted mempools emerge. So, someone else could start a new one with a different threshold set. So if you prefer to use that, then you can trust that threshold set. But I think it doesn't kind of make sense to bring that into the protocol at the moment, because really, I think the only way to actually accomplish this is using threshold encryption. So if we're thinking about Ethereum L1, I don't think it's possible to run threshold encryption kind of with all of the validators at the moment. So you kind of have the question of who would this threshold set be for L1? Like, how would you set it up? And I just think that the technology is not really there yet that we could do that. So it makes more sense to have, different smaller kind of individual encrypted mempools with their own threshold set, and then you just choose the one that you trust.
Although there is that there's that ability with the silent threshold encryption that you can so set up the DKG with a really large set of actor nodes, and then later subsample and have like subsets of this to collaborate, right? So I think cryptographically there is a solution to that problem as well.
Yeah, I think that could be useful, but potentially it still might be difficult to pull off on sort of L1 at the moment. And I think there's like, trusted setup ceremonies and like various things that would make it difficult. But yeah, I mean, that's kind of a way that, say, for instance, Shutter or anyone else could have like if they had a really large threshold set, then that can add a lot of trust. But of course, you always have to have this trust that 2/3 of the current threshold set aren't going to collude. That's kind of the fundamental trust assumption.
Yeah, that won't go away. But I think that even the setup, I think that's what this called silent threshold encryption means. You don't need the setup or something. I don't know. It's like I think there's some pretty cool stuff to. Yeah, I think that will be possible at some point too, or not even like will be possible. I think the cryptography for that works already. It just needs to be implemented.
Okay. My last question is like to make encrypted mempools a reality on Ethereum. So what concrete milestones, be it like testnet pilots or EIP drafts or cross-client standards, what kind of milestones should be the community rally around in the next 12 months? So Luis, you might start.
Definitely as a next milestone, our side, the one that Ben has hinted on before. So the idea there is leveraging builder and proposer commitments to implement an encrypted mempool out of protocol into the PBS transaction supply chain, essentially. And then we would leverage PrimeMev's MEV commit. And we're currently building a POC for that together with the PrimeMev team, right? So it'll essentially look like that Shutter would be a sequencer provider in their system, and that it will sort of encrypt transactions and then try to offer them to the builders in the system and receive first a builder commitment, and then later hopefully we can extend it to also receive proposer commitments that your transaction will be included, and the builders and proposers would commit to the inclusion of these. Right, so yeah, and that would be a really cool milestone to be able to say, hey, we can build the auto protocol, and then making also the case that if we can build it out of protocol, that's also a good case to build it in protocol down the road. So then the next milestone, next big milestone I would see really is what we talked about before. This how does Fossil, EPBS, and Encrypted mempool work together at the protocol level to provide this really high level of censorship resistance and front-running protection together. So yeah, that's the longer term milestone. And I think in terms of EIPs, I think that there we definitely need to coordinate a little more. So definitely Mark has written some really cool EIPs. We haven't done one yet, so I think we should align these EIPs. Ideally, have sort of like maybe one or two big ones that we could rally around, that we can like present. So we're just not at that stage yet to have an EIP ready, but I think that'll also be something that we should work on and coordinate around, and then kind of bring that into these cool lists, that the Amsterdam list, whatever the next one will be. Yeah.
Nice. Mark?
Yeah, so the main thing for me is this EIP, so it's EIP 7793. And the aim of this is to kind of give better support for encrypted mempools. So it can kind of generally give like a much higher kind kind of bar or like reduce a lot the kind of trust. So to kind of give context, at the moment in Shutter, the proposer is kind of trusted. So that means that when your transaction is decrypted, then you're kind of trusting the proposer is actually going to still not front run you. And that's what Lewis was talking about with the kind of proposer commitments as a solution to this. So this kind of goes some of the way, because now if the proposer kind of attempts to front run, so they like kind of reorder the transactions and don't put them in the order that they should have, then they can actually get slashed and lose some money. But then with this EIP, it goes to kind of an even higher level of security, where now whatever the proposer does, it's actually impossible for them to reorder and include your transactions. So otherwise, you could always have the case that, say, the proposer is going to get slashed, I don't know, a few $1,000s for reordering the transactions, but they can see that from the MEV, they can actually make more money, then they might just kind of rug everything and do it anyway. Whereas with this, it becomes actually impossible to execute those transactions if you're going to reorder them. So yeah, that's proposed for Glamsterdam. And yeah, if anyone's interested, then it'd be great to get more support or any more feedback on that EIP.
Okay, EIP 7793. Yes, anybody interested, please go search it and check it out. Okay, so yeah, is there any more questions from the audience here? So please raise your hand. No? Okay. All right, that's it. Thank you guys for being here, and very much thank you for Luis and Mark for being our great speakers and sharing all their viewpoints on encryption pools. Hopefully, it will be implemented into the protocol, and let everybody don't need to worry about sidechain. So, okay, thank you guys. Thank you for being here.
Thanks so
Cheers.
much.
Great to be here.
Great.
Thanks for being on, guys.
Bye.
Okay, bye.